Good afternoon. Welcome to our webcast from the living room to the control room. This is part of the Emerging Technology webcast series put on by SIA and the Security Industry, SIA, the Security Industry Association, and SSN, Security Systems News. Today's event is sponsored by Axis Communications and Hikvision. Axis offers intelligent security solutions that enable a smarter, safer world. As the global market leader in network video, Axis is driving the industry by continually launching innovative network products based on an open platform, delivering high value to customers through a global partner network. Axis has long-term relationships with partners and provides them with knowledge and groundbreaking network products in existing and new markets. Axis has more than 2,000 dedicated employees in 49 countries around the world, supported by a network of over 75,000 partners across 179 countries. Founded in 1984, Axis is a Sweden-based company listed on NASDAQ Stockholm under the ticker Axis, AXIS. For more information about Axis, please visit our website at www.axis.com. And then Hikvision. Hikvision is the world's largest manufacturer of video surveillance solutions, featuring the industry's strongest R&D workforce. Hikvision designs, develops, and manufactures innovative standard and high-definition cameras, including a variety of IP cameras, analog cameras, and cameras featuring the latest in high-definition analog technology. Hikvision's product suite also includes digital video servers, hybrid and standalone DVRs, NVRs, and other elements of sophisticated security systems. For more information, visit Hikvision, www.hikvision.com. So today's panel, let's see, we've got James Marcella from Axis Communications and Doug Gray from Hikvision. Let me just tell you a little bit about them before we get started. James is the Director of Technical Services for Axis Communications. In this role, Mr. Marcella oversees technical support and industry associations for North American operations. Mr. Marcella joined Axis in 1996 as a business development manager. In this position, he managed the company's application development partner program for North America, finding best-of-breed software developers to create applications specifically for Axis's network video products. He later served as the government solutions manager and was responsible for developing the company's authorized dealer channel and growing business in the federal market. Mr. Marcella has represented Axis at a number of high-profile events, including ISC West, ASIS, and TechSec. He is an instructor for ASIS National Education Program and a member of the leadership team of the ASIS Physical Security Council. James often contributes and is quoted in a variety of security and IT publications. Doug Gray from Hikvision. He is Senior Product Manager for Hikvision USA and Canada. He is responsible for the entire hardware product line, including IP and analog cameras, digital and network video recorders, user interfaces, and accessories. Doug manages product development, technology applications, processes, and procedures to ensure Hikvision's incomparable growth continues efficiently and effectively. Doug brings over 25 years experience in a wide range of positions. These include Director of International Sales, VP Product Development, VP Business Development, Systems Engineering Manager and National Account Manager in global companies such as Calatel, Interlogix, and GE Security. With this background, he has developed the field experience to understand customer-facing requirements, big picture vision, and the drive to make that vision a reality. Doug's unique blend of business and technical savvy is key to developing Hikvision's product future. So, James, Doug, thanks for joining me today, and I think we've got some interesting things to leave with our attendees. So, James, I'm going to turn it over to you. You can start the party here.
Great. Thanks a lot, Tim. I want to start by thanking the Security Industry Association and your organization, Security System News, for allowing us to participate today. Really looking forward to getting this information out to all of the attendees. So welcome to this introduction training on 4K. Our goal is to provide you with the basics or a foundation of this video standard, the benefits as they relate to the security industry, the challenges for implementing it, and really where we see the biggest use of the technology, including a case study of an existing deployment.
Hey, James,
maybe
if I can jump in real quick. I just want to go to the title of the event, which is, from the living room to the control room. I'm going to ask both of you. Do either of you have a 4K TV in your home? And if you don't, why not?
Well, this is James, and I do not have a 4K TV in my room. They haven't come down in price yet to the point where I'd be willing to purchase one, so that's why I haven't.
Yeah, this is Doug. I think a very similar answer. Don't have one at this time. Haven't really seen the need, honestly. Broadcast TV typically is not going to be in 4K, so I haven't really seen a need as yet.
Awesome. Okay. Go ahead, James. Sorry.
Doug brings up a really great comment, and that is, the content just really isn't there to really justify it yet. Interestingly enough, on the security side, I think the security industry will have the ability to drive and develop more content for 4K television sets than the entertainment industry will as these products get deployed out there. We do have a 4K TV in our technical services lab. We just purchased it, but no, I don't have one at home yet. So, but most of you have probably heard of 4K. It's been around in TVs for a while, as well as handycams. About a year ago, was introduced into security cameras. 4K is basically a resolution, which is 3,840 pixels by 2,160, which equates to approximately 8 megapixels. It is a standard, so it actually encompasses more than just a resolution, and we'll cover that in subsequent slides.
Yeah, and I would mention, James, that even though it's 3840, the standard 4K was based on 4,096 by 2160 in the broadcast area. So just don't want to confuse people and think, what does 4K mean? It is actually 4096 by 2160 on the native side.
That's a good point. So some general information about 4K. So this is a standard that was approved by the International Telecommunications Union and Society for Motion Pictures and Television Engineers. It's a standard that defines more than just resolution. So first off, we started resolution. We talked about an 8 megapixel image. It's also an aspect ratio, so 16:9 aspect ratio, which really matches the existing displays that you'll be purchasing and deploying in security control rooms or head ends. You'd probably be hard-pressed to find a 4:3 display anymore, although I'm sure there might be one or two out there still. Frame rate. The 4K standard, or the HDTV standard, defines that it has to be able to deliver 30 frames per second, but the standard actually covers up to 120 frames per second, but it's not a requirement. Just because the camera can do 30 frames per second does not mean that you're going to actually record or view it at that. Most security professionals are not recording at that level based on some bandwidth. There are many instances, and then when you look at the image from a camera on a display, the colors just don't seem to match up. These differences can sometimes be costly from a physical security perspective. So what we're really seeing here is a repurposing of consumer electronics technology, and unlike previous game-changing tech, such as the initial development of HDTV or adoption of HDTV in the security industry, or even video compression standards like H.264, the security industry is always lagging a little bit and is a few years behind. What's interesting, though, is we've actually caught up, or we're getting better, because it took us about 7 years for us to adopt H.264, and we're only a couple of years into really 4K being available on the consumer electronics side, and here we are already talking about it. So this next slide really just represents a 4K screen, and we're going to go through the different resolutions associated with it. So if we look at these other resolutions, we start with VGA. This is how much of that screen VGA would take up, 640 by 480, the basic classic old computer screen resolution. Jumping up to 720p, you can see the aspect ratio changes a bit. We get to the 16:9 aspect ratio, and again, a little bit more of that screen gets taken up. Full HD TV, as they once called it, 1080p, is a quarter of the size of a 4K monitor. Looking at 3 megapixel, notice again the aspect ratio changed over to 4:3, and 5 megapixel. And then really getting all the way up to 4K. And as you can see here, with 4K, I think one of the biggest impacts it will have on the security industry initially, beyond edge-based image capture, is on the display side. The idea that we can actually display 1080p video in its native resolution on a monitor, and in this case, a quad view. We could have 4 1080p videos viewing them in their native resolution. We could have 8 720p videos in their native resolution. This is where I think 4K will have a little bit more of an impact for physical security as opposed to security camera side, which I think right now is more of a niche type of solution. But we'll talk a little bit more later on the different areas of deployment for 4K to date.
Yeah, I wanted to also point out, it's interesting that we're talking about 1080p typically, which is your vertical resolution. When we talk about 4K, we're kind of talking about our horizontal and vertical resolution. So I'm wondering if in the future we might start talking about the 4K as actually 2160p. Which is similar to your 1080p in terms of discussion of resolution vertically.
Yeah. The next slide here really is that same, is very similar but just in chart format. The number of pixels will increase with each subsequent jump in resolution. But remember that the sensors are more or less the same size as before. So the resolution increases, the pixel size, the size of those pixels on that sensor are actually getting smaller. And you'll hear from Doug a little bit later that poses some interesting challenges for 4K's use in physical security. 4K is a... Sure.
If I can, Jay, what's really the significance of the aspect ratio for the security professional?
The biggest significance is really the displays that you're going to be viewing them on. So most displays manufactured today are in that 16:9 aspect ratio. Most television sets, most folks probably have a 16:9 aspect ratio television set at home. So it's really matching that the display to the image capture that has the greatest significance for.
Gotcha. Thank you.
Aspect ratio. Sure, absolutely.
Okay.
So I just wanted to point out, I have down at the very bottom 8K. 4K is obviously not the end of resolution development, and in fact, you can find higher resolution cameras on the market today. They don't necessarily conform to HDTV standards, which, as we learned earlier, cover so much more than just resolution. The next advance in HD will be 8K, but about 4 times the resolution of 4K. Not something that I think you'll see on the market within the next couple of years, but I don't have a crystal ball in front of me. So next slide. Talk a little bit about bandwidth and compression and what that means. As we increase the resolution, we obviously increase the bandwidth and storage requirements. For example, 4K is going to consume a lot more bandwidth than 1080p. On average, we're seeing that 4K is consuming about 10 megabits during the daytime. When you get into low light situations, so I have nighttime up there, but it really should be low light, the bandwidth increases quite a bit more. We've seen about a 50 megabit increase there, but I'm sure all of you would be able to find a scene where it might increase even beyond 50 megabits per second for 4K in those difficult lighting conditions. And I think
so
one of the questions...
I was going to say, explain if you can, why in low light?
I was anticipating that question there. So so at nighttime or in low light conditions, noise gets introduced into the image, and noise can be visibly seen in an image. Typically, it's that sort of snow effect. You see little pixel movements and things, and that's all throughout the image, particularly in darker areas. Those little changes get recognized as movement by H.264, and it's the movement in H.264 that generates bandwidth or the changes from one scene to another. So when you have a lot of little moving pieces going on, bandwidth and storage requirements increase, and noise gets induced when there's typically low light scenarios.
Okay, thanks.
So why 4K? What are some of the benefits here? Well, as we stated, it's all about the resolution. More pixels gives you more details, and details can be all the difference in physical security situations. When looking at the car park or a public square, as you can see here, those more details provide you with better situational awareness, as well as the ability to discern objects within the image that you might not be able to when you digitally zoom in. So looking at specific benefits of 4K, I've really looked at and divided these into three main areas of benefits, those relating to physical security practices, image usability, which is indirectly or directly related to physical security depending on the situation, and then digital PTZ. But let's start off with operational requirements. So as security professionals, we really leverage video primarily for verification of events, and typically that's done after the fact. Traditionally, video has been a reactive tool. That's changing, though, as improvements are realized through the use of video analytics. Imagine using video to proactively notify a security professional while an event is unfolding and mitigating that risk sort of on the fly. Analytics is not necessarily the purpose of this presentation or this webinar, so that'll be a topic for another day, but we will get back into analytics in a little bit. When we talk about operational requirements for video, we're generally looking at three categories, which are defined by the amount of pixels on target to achieve them. So detection can be accomplished with less than 1 pixel per inch. Recognition can be accomplished with as little as 3 to 4 pixels per inch, whereas identification requires at least 12 pixels per inch or 80 pixels for the width of a person's face. Higher resolutions such as 4K enable the security professional to cover a broader area while maintaining pixels on target to achieve the operational requirement. So when we go back and really look at situational awareness, when I talked about more pixels on target, so leveraging a wider field of view provides a better overview of the entire area, and thus gives you better situational awareness. An example would be, take your standard elementary school auditorium. You're tasked with identifying a person walking through double doors. This could easily be accomplished with a VGA resolution camera that is properly placed and has the right lens combination that's going to provide you with 80 pixels for the width of a person's face as they come through those double doors. With that resolution, most likely you're only going to record the doors as well as maybe a few feet around the doors. Now take that same scenario, but use a 4K camera. We can place that 4K camera much further away from the door. We can provide a wider angle lens on that camera. So not only do we see the door, but we actually see what's going on within the gymnasium. If not the whole gymnasium, maybe a portion of it. It really depends on the size of that room, right? But we're able to continue to maintain that pixels on target to meet the operational requirement of identification. So it's really just pulling the cameras further back, wider angle of view. You see more of what's going on within the gym, and now you're also or still able to maintain that pixels on target. And the school resource officer would be able to identify people walking through the door as well as what's going on in the gym. Analytics developers also typically provide a recommendation or a minimum requirement for pixels on target to properly work. The same argument that we just talked about with situational awareness and using a wider field of view also would apply to analytics in that case. Many people also talk about image quality, but in reality what we should really be talking about is image usability. If an image is usable for a security professional, it will meet the operational requirements like we just discussed, as well as provide situational awareness. Situational awareness includes understanding what is happening at the scene, but also reproducing colors more accurately, such as the color of a car or personal characteristics such as the color of a person's hair. Frame rate is just as important, and you can tell more about what is happening at a scene if you're looking at it at 15 frames per second than, let's say, 5 frames per second. As stated earlier, 4K covers not only resolution, but it also covers color rendition, frame rate, as well as the aspect ratio. Higher resolution cameras enable you to digitally PTZ using a fixed camera. Without moving parts of a traditional PTZ, these cameras are less expensive and require less maintenance over their life cycle. At some point, digital zoom decreases image usability to the point that renders it useless, and digital will never catch up with optical zoom. So tread lightly when you look at fixed cameras and digital PTZ. Make sure that you test it before you put it in place and that you're meeting the operational requirement before deploying it. So the next few slides will really just show some images from some 4K cameras and giving you some comparison shots here. So what we're looking at is a view out of our corporate headquarters in Lund, Sweden, looking at the S5 building, which is about 3 football fields away from where this camera is. The views are from the roof looking over. You can see that at 720p and at 1080 and at 4K. When we digitally zoom in, you can clearly see differences in image usability from one resolution to the next. In this next picture here, this is a 4K overview of the Öresund Sound between Denmark and Sweden. Out here in the distance is the Öresund Bridge. If you ever come over to Sweden, that's how you'll get over from Denmark if you're flying into Copenhagen. But anyway, looking down here at all these different apartment buildings, there's an object down here in this corner that I can see is a fairly large object, but I can't really identify what that is. So let's digitally zoom in. So this is a quarter of the view at 1x digital zoom, and I can still see that I'm not quite sure what actually this object is right now. So I'm going to zoom in one more time, and now looking at this image, I can see that this is a dumpster and that this is most likely activity from construction in one of these apartment buildings here. But really, it's about forensic details and the idea that I can digitally zoom in after the fact and get some additional details within the image that I didn't have originally helps with forensics investigations after the fact. My last few slides are about a specific case study at the University of Miami that deployed 2-axis 4K network cameras at the Mark-Light Field at Alex Rodriguez Park. When we look at this, really the cameras were put in to give a general overview of the seating area. The field of view at 107 degrees by applying 2 of them. You can see one shot here of these really gave them enough details to meet their operational requirements. They've also added some additional 1080p cameras throughout the stadium to cover choke points such as entry and exit areas, concession stands, and other areas of interest. When we look at the operational requirement, what they were trying to do with these 4K cameras is really just recognize, so 3 to 4 pixels on target, recognize attendees in the stands. An interesting note, and it kind of goes off and talks a little bit about analytics here too. One of the cameras was actually hit by a fly ball, and there's an analytic on the cameras that will notify you if a camera goes out of focus or if it is obstructed in any way. And yeah, so one of the cameras took a shot by an 80-mile-per-hour baseball and proactively alerted folks that it was out of focus so they could come and fix that, actually fix it remotely through remote zoom and focus. This shot here, remember we talked about the operational requirement and image usability. So what they wanted to do was be able to recognize folks in the stands with these overview cameras. So from this camera view, University of Miami police officers are able to recognize people sitting all the way in the first row. So if you saw these two people down here, I'm circling them with the mouse, right? We can see that one man is wearing a white shirt, the other one's wearing a blue or a black shirt. One has a baseball cap on, one does not. And we can certainly use this to recognize and potentially resolve any disputes that might come up with what could happen at a sporting event during one of these games here. So that really is it for my portion of this presentation. I want to thank you for attending this today and listening in. Please feel free to reach out directly to me or your local Axis rep for any more additional information on this solution or anything else we do. Thank you.
Thanks, James. We're gonna turn it over to Doug from Hikvision to kind of give his perspective of 4K. So, Doug, it's all you.
Hey, terrific. Well, thanks very much, Tim. And again, I also thank everyone for joining today, and thanks so much for sponsoring this, SIA and SSN. James, some great information. I think a lot of people have learned a lot in the first few sets of information here. What I'm going to be covering is really what's happening in the marketplace, the trends that are driving some 4K technology and usage, and also those challenges that we've talked about already, how we address those challenges, and as well as what really we see in the future of 4K and what you can look forward to. So let's start talking about a little bit about the trends driving 4K technology. We talked about the fact that, hey, not a lot of us really have 4K monitors at home. Broadcasters are not broadcasting in 4K. So the demand for monitors has not been very strong of recent times. However, there have been some growing trends in the area of movie making and film producing that have started to use 4K technology. We know that the Amazon and the Netflix services are now streaming 4K content. So that's creating a lot more opportunity to use a 4K monitor at your home and really get the advantages of the full 4K technology. In the recent times, we've had the 2012 Olympics in England, or from London, and that was broadcast in 4K. So again, driving a little bit more interest in 4K technology and in broadcasting, so we can actually use a home monitor to view that high resolution.
So Doug, if I may,
yeah.
You and James both said you don't have the 4K monitor or screen TV at home. Where's the cost going? When do you expect that it's going to be a little more palatable for folks like us to purchase a 4K TV and actually take advantage of what these guys are streaming?
Well, honestly, it's really coming into play today. Probably 2 to 3 years ago, you were looking at about a $2,000 cost for a 50-inch 4K monitor. Today, you can probably get that same monitor for in the area of about $700. So they're becoming much more economical. We're seeing a lot of sales on 1080p monitors. They're clearing some of those out, just as we saw with the 720p monitors. So I think that, in fact, now is really the time we're starting to see 4K take off in the consumer marketplace a lot more. In fact, just this past May, Blu-ray has started producing 4K DVDs, and so we're starting to see Blu-ray players playing 4K DVDs. So that's also a trend that's driving some of the consumer and home use. And that will translate into the security market, I think, soon as well.
Okay.
On, obviously, 8 million pixels, a great amount of image quality is provided. James overviewed what you get when you see a scene, a wide view scene, and the kind of images that you can get. So technology always is going to drive ahead to improve quality of image, and in our marketplace, image is extremely important. James has mentioned video analytics. Again, there we have seen sometimes a bit of a higher expectation from analytics than we're actually getting in our applications today. We're not getting perhaps what we expect in terms of identification and tracking that we might be hoping for in some of our applications, but 4K increases that really 4 times of what we've seen in the past. 1080p has been your best resolution, 2 megapixel cameras, but today with the 4K resolution, we can actually improve all of those analytics that we've used in the past. We can detect things much sooner, we can track things much easier, determine between vehicles, between people, between other objects much more readily. Face detection, real important part of our security business today, especially in the case of issues where we're trying to find individuals that look suspicious or people that are in crowds that we know are criminals. So face detection, very critical importance in a lot of applications, and in that case 4K does provide a tremendous amount of improvement. When we look at the other business areas where image is important, digital photography, we're seeing that 4K or 8 megapixel sensors are becoming much more standardized based on the fact that they do provide the best solution in terms of the low light performance and resolution in digital photography. So these kinds of things are making 4K much more important, much more interesting, and in fact driving broadcast, movie makers, as well as security companies to move more readily into the 4K technology market. So we talked about a few of the challenges, and I think one of the most important is obviously the high resolution and how we handle that in our systems today. It's going to increase bandwidth requirements in our systems. There's no doubt about it, obviously. We've got a great deal more image information to process, 4 times more in fact. We've got to store that information, and computers are going to have to decode that information. So there's a lot of effects to your overall security system simply because you've got a great deal more image to process. So we talked about the fact that 4K is about 10 megabytes per second on average. That's really 3 to 4 times 1080p. And talking about what James mentioned earlier, if we're looking at a recording of, let's say, about a month's time, 25 frames per second, on 1080p, you're going to run about 2 to 3 megabits per second. On 4K, again, we said 10 megabits per second. So that's 3.5 times more bit rate. That translates into about 770 gigs of storage space for 1080p, and on 4K that translates to really 3 terabytes or 4 times more storage requirements. So again, significant effect in our recordings, in our displays, and our processing equipment. When we talk about the sensors themselves, the actual equipment, the hardware that's being used to provide this 4K technology, you're going to have really the same size sensor in our cameras, but they're going to have twice as many pixels, or sorry, 4 times as many pixels. So that actually causes pixels to be smaller in size, and they're not going to perform quite as well as the larger pixels would. So low light performance is a factor. Wide dynamic range, which is something that is widely used today in correcting image views, the ability to adjust the light conditions that you're seeing through those sensors. And the most important probably part of this is the fact that your optics that you're using on current 2 megapixel cameras are not going to be suitable for a 4K sensor.
So, Doug, if I may, there's a question that came in that says, And I like how this is stated, would a camera with a 4K sensor, but with a crappy lens, still put out a 4K quality video?
Well, absolutely not.
Yeah.
What we're looking at is obviously a much more defined area in terms of the pixel array. And in order to translate the image from the pixel array through that lens, your lens has to be able to accept a very fine detail. And obviously, optics are typically rounded or curved. And at the edges, in many cases, the image resolution falls off. And in a 1080p or 720p type of a application or sensor, that fall off at the edges is not going to be as critical because your pixels are much more forgiving. They're much larger, and your central area of images is going to be quite clear. But when you're talking about much more pixels onto a sensor, the edges become much more critical in terms of performance. So you do need to ensure that you have a 4K lens or an 8 megapixel lens being used with your 4K camera to get the full resolution from those edges and throughout the image with those smaller pixels. So let's move on to how we're addressing these challenges. And we mentioned that bandwidth is a significant challenge, and I think everybody recognizes that. And some of the ways that we can address this and in fact start using 4K today is variable bit rate streaming. This is where you're able to record or view live images in a different resolution than for perhaps the full 4K resolution. In fact, that's being done today. We do have 2 megapixel cameras, 1080p, and we do reduce streaming to save recording space, go down to 720p, for example, to record particular scenes. If there is an important event, then we can move back up to a higher resolution and record that. So adjusting your bit streams are something that available today on most products in the security marketplace if you are doing network recording. And that's a huge advantage in terms of having the flexibility to use 4K today, but perhaps not record full 4K images. Another area where we see that bitrate concerns come into play are also in our VMS platforms. And similar to variable bitrate streaming that we have, in the VMS platforms and on CPUs, there is an ability to do dynamic stream control. And so your VMS platforms will also have the ability to process that 4K if they're doing dynamic stream control. In addition to that, there is a technology that's being done called GPU decoding, graphic processor unit decoding. That means that rather than using your graphics card or your CPU to do all the decoding, you're going to be using your graphics card to help you do the decoding. So the strain on the CPU processor itself is not as great. And so, again, VMS solutions, computer processing rates do accommodate different bit streaming, different ways to accommodate the higher resolution. So there are ways to address that bandwidth issue in those areas. Another area is multi-stream capability. A lot of our cameras today have the ability to have 1, 2, and even 3 streams coming from them, and therefore we can use those streams in various ways. A stream for live view where we get the full advantage of 4K resolution. We can also continue to stream in our recorder at a lower bit rate, a 720 rate, for example, or 1080p rate. And again, a third rate could be used for sending images to other locations. And again, varying our bit rates on a multi-stream product is a great way to take advantage of 4K, use it when you need it, but maintain your processing and your recording capabilities that you have today. Some other ways that we're addressing bandwidth is optimized H.264. James mentioned this decompression technology, which is common today. for most manufacturers, but Hikvision as well as Axis have introduced ways to reduce the bit rate through different processes and algorithms, and really get even up to 50% reduction in your bit rate. So again, we're looking at a reduction of using 4K streaming on today's products, where you can actually get a 50% savings from your devices in bit rate when you're using 4K or any other transmission rate. And lastly, H.265 is a new compression technology coming out. It has been discussed. There are some products in the market today. It's really limited in terms of exposure at this time, particularly because there has been some questions as to licensing and cost of licensing. There has been a group that has introduced royalty, the HEVC Advanced Group, which really manages the H.265 compression. They're looking for royalty on usage. So that's still an open question as to what happens in H.265 in the near future. But it is a compression that has been developed and is available. And we may see some products coming out in the near future that will, in fact, provide, again, an additional reduction in bit rate usage for these high-resolution products. Looking at sensor size as another drawback in terms of 4K technology, we already spoke about the optics. So it is critical that you do have matching optics for your 4K products when you do use 4K. Low light capability is reduced in your 4K products because of the millions of pixels that we're dealing with. So IR illumination is a good way to overcome this. A lot of camera products today have built-in IR, or you can add additional IR to illuminate the scenes in those low light conditions. And also noise reduction technology is becoming more and more common. We're seeing ways to reduce noise in products, and you'll find several manufacturers that have implemented noise reduction technology that improves the image qualities of current products as well as the new 4K products. So what is the outlook over the next few years for 4K or Ultra HD? James, did you want to address some of these? I know you were interested in talking about some of these points.
Sure. I think what we'll definitely see over the next few years, an increased use in 4K products as they become more available in different form factors. I think you'll see security professionals finding places where this standards-based technology can be used more. We both, Doug and I discussed this earlier, both agree that it's still going to be quite a while before we see wide usage of this, not just from the camera form factor and availability of products out there, but also for the ecosystem, which includes, ensuring that you have the correct bandwidth, and obviously storage becomes a big issue here. So 18 months to 2 years before we really start seeing 4K really start to take off on the edge. As I said earlier, I think the use of 4K displays in control rooms and head ends will happen at a quicker pace than that, but on the edge it's still going to be a number of years off. Thanks, Doug.
Yeah, thanks, James. Again, additionally, the wide dynamic range is still going to be a factor, and that is a limiting factor. So until that becomes overcome more so, I think we'll see a slower acceptance of 4K, especially in our more complex applications. And as in the broadcast industry, we have seen encoders coming into play that provide real-time video compression. So we can implement 4K today because we do have the real-time encoders available. The 12 or 16 megapixel products coming in the future, I think James mentioned the 8K as a potential product coming along. Those, and I think until they're accepted and starting to be used in the commercial applications, the broadcast film industry, and real-time compression capability is available, those are going to have to wait some time before we see really any growth in those particular sectors. We already talked about the fact that today even 1080p cameras are being recorded and viewed in a 720p format, so we're not using much storage. I think we'll see the same thing continuing in the 4K applications. People will take advantage of 4K for specific applications. As we saw in the University of Miami Stadium that James showed, in that particular stadium they're really only using 2 4K cameras for specific overview scenes to get more detail. And so I think similarly in use of 4K throughout the industry, we'll see usage in specific applications where it fits and where it can provide that extra bit of technology improvement in image. We'll see more use of that. Cost obviously is still a factor. We don't own 4K monitors because they are costly. Same thing, 4K camera products, 4K recorders and so forth do demand a premium at this point. I think you'll be looking at a 30 to 40% premium in most cases on 4K products. So as that price comes down, then again we'll see more usage of the 4K products. And then lastly, obviously, solutions are going to need all the different components to make up your 4K solution. The optics, the encoders, recorders, faster computers, and then those 4K displays. So where's 4K being used most commercially? We've talked about the large public areas, those stadiums like James showed. Hikvision has been involved in several applications involving city surveillance, traffic applications, identification of vehicles versus persons, face detection in large areas like exhibition centers or airports and things of that sort. Using that electronic PTZ for tracking and face recognition. Again, good applications for high definition requirements. Homeland security, high-risk surveillance. We are definitely seeing governmental agencies, militaries are using 4K in a much more effective way today. They're a real prime target, I think, for application of these products. So if you do have governmental accounts or governmental or military applications, very, very much a prime opportunity to introduce the 4K product and its capabilities. Retail industry, here we're finding a lot of usage, maybe not so much for security, but for business management, identification of products on shelves, reading SKUs, looking at face recognition. All those kinds of things really benefit from the 4K technology. And then the video walls. Now today you have large screens available that are being used in security control rooms, and in those cases these multi-screen displays are very effective. In addition to that, you'll find these video walls or large video displays in shopping malls and display locations where high pixel density is very important for very, very clean looking images. So in those areas we certainly are seeing 4K applied. The last couple slides here really just kind of show what 4K looks like in an application of a video wall looking at a traffic scene, where we're going to show the ability to zoom in to that particular scene on a sector of that view where you have very high resolution. I have a short video that goes through that. We're going to show the Hikvision resolution application where video streaming through an HDMI 2.0, I should mention that HDMI 2.0 is the preferred method of displaying 4K because it does allow for the higher resolution transmission. And then continuing through, we just see how that image quality retains itself when it is brought into a zoom in a traffic application. And again, looking at the Hikvision solution, showing on the left the conventional 10 to 12 megabits per second, and then using the optimized H.264 plus, where we've reduced that down to 5 or 6 megabits per second, saving storage space tremendously. So that wraps up my portion of the presentation. Thanks so much. Turn it over to you, Tim.
Doug. Thank you, Doug. I appreciate it. And yeah, really, I just want to thank you and James for a great presentation. There was a lot of information here. This will be, on a recording that folks can go to on demand and view it. I want to thank Axis Communications and Hikvision for sponsoring this event, and of course, thank you everybody for attending. Greatly appreciated. So until next time, thank you.
Thank you.